I will take 2 more minutes just to brief you in short about Sela Technologies and what we are doing successfully, how we are helping our existing customers. As as a global company, Sela Cloud is a global partner of Microsoft Azure, MSP partner in the region of Middle East and Africa. We are also a core partner of Microsoft. We have our office in India. Israel is our headquarter. We have our offices in Canada, the US, and the Singapore. Our expertise are into working in Windows projects, application modernization, system design, data modernization, DevOps and CI/CD, analytics, data center migration, and cloud security. Today, we are glad to have Kfir Gurari as a speaker in between us. The topic he will be discussing, as we know, Azure Data Explorer deep dive. So, Microsoft. So, Microsoft, a data and AI solution specialist. He has a depth understanding of artificial intelligence, machine learning, and data processing services in Azure. He also had co-founded a company working in data and AI solutions. We are proud he is working with us and leading the team of data and AI experts in Sela Technology. I'm putting my email address and contact details in the chat just in case anybody want to discuss anything more later in this event, later after this event, so we can connect. Kafir, handing over to you now.
I want to start with a small demonstration about what you can achieve using it. So I will pause my video and I'll tell you a bit a story. Now, during COVID, different waves in Israel, we started working a lot, mainly actually from home. And I find myself doing a lot of working with meeting customers and making webinars and teaching all kind of customer all around, all over the world. So I found myself more than 10, maybe even 11 hours sitting in the sitting position. One day my wife came and approached me and said, "Listen, Kfir, you're forgetting to drink water." I said, "No, come on, you're wrong." So she said, "No." So I thought myself, okay, I will show you what I can do. I will take technology on my side and let her see that she's wrong. So what I actually did, I took a simple cognitive services solution based on custom vision, and I took a lot of samples of myself drinking water from all position. You know, I took a 360 of myself drinking water, and I tagged everything, and it was awesome. I said, okay, this will be the first time that she see that she is wrong. So hi guys, this is myself. This is a live video, not from Teams, but from this application. And over here on the bottom left side, you can see the text that I am currently not drinking, which is true. So I took a glass of water. And it's still not detecting. No, just kidding. It's really easy in detecting when I'm drinking. And I took everything and embedded in a really decent application that start counting how much time I'm drinking in every single day. And you know what? At the end, she was right. I was wrong. I didn't drink enough. So this is one example of what you can do with AI and visual. So another example is taking it further and trying to help you in your organization or your customer and employees detect whether they are wearing or not wearing mask, which is really important today. So you can see the AI actually detect whether she is wearing a mask or not. In other scenarios, you have simple gauges that are actually analog, and you want to see whether it becomes danger. So let's run the video, and you can see when it reaches the red area, a simple camera can detect that it's becoming a dangerous situation. When you're looking, for example, at the forest and you want to see, to know where you need to focus on deforestation environment, so you can see here also a scenario of deforestation. Another scenario handles the risk detection, whether it's smoke, whether it's indoor or outdoor. Over here you can see smoke detection versus fire, which is also a simple way that you can take a camera and achieve this goal. And if you are working in a retail environment and you want a simple scan of whether it's pepper or onion or other and shorten the queues line at the retail store, you can use this technology also. Or if you are in a training mode and you want to figure out whether we are crunching or not, so you can count how much crunches I did every second. And if your employees or your child or your daughter is sleeping and you want to a small alert when she's become awake, so you should approach her. Over here you can see a simple, neat example that you can take it, take the machine and learn how to realize when the eyes are openly wide. When I'm talking about Azure AI, we have three main pillars: the AI application agents, machine learning itself, and knowledge mining. At this session, this current session, I'll focus on machine learning itself. I will focus on Azure Machine Learning. So what are the actually building blocks for data science project? So everything, as you realize, starts from different data sources. You want to build models and train them, whether it's classical machine learning or deep learning. You want to generate a high performance tuning and experiment the pipelines. You want to and deploy the solution to production in order that you can inference the information and generate meaningful insights. Meaningful insights that at the end might even generate value and actual business value to you. So what can make it simple? You can understand that it's really complicated. Azure Machine Learning Service allows you to take a cloud service and use the Python SDKs in order to enable you preparing the data, building different models, train them, manage them, and again, track experiments or make experiments, deploy the model to production. And so as long as you require, you should train the model. So how Azure Machine Learning Services can achieve this object or can help you achieve these goals. So let's assume that you want to realize how much a specific car is worth, it's currently worth, okay? So as I told you before, you should gather the data and prepare it, shape it, build and train the model and deploy it. Let's start by preparing the data. You receive from many sources different data in different shapes, and you need at the beginning to organize them. Then, after the data is organized, you can input it into the building and training stage. And what does it include? For example, in our scenario, the business goal is to detect what is the car value based on car rent, the year of make, and the mileage. So you will take everything inside the model, and you'll use a machine learning CLIs or a VS Code or a Jupyter Notebooks, and you will bring it into the machine learning environment, and you can deploy it to your local machine, like I showed you in my example, or you can scale it with Azure Machine Learning Compute or with other Apache Spark compute in the cloud. At the end, you want to take the most accurate model and deploy it to production. So when I'm talking about deploying, you can really figure out that you can take it and wrap it inside the Docker container. You can deploy this Docker container to your on-prem environment, whether it's your PC or laptop. You can deploy it to an IoT edge, whether it's smart like an actual server or a Raspberry Pi. You can deploy it to an Azure container instance. So I spoke about all these processes. At the beginning, everything starts with the different data sources. So it includes the SQL DBs or Cosmos DB, whether you have data that you are keeping in your data warehouse or huge data lakes. And of course, the blob storage. Not all of us have the ability to hire a data science. So Azure Machine Learning might be the first entry point for you to try to realize how much this car worth. And in the couple of slides that you'll see, I'll show you how simple is it to do it today. When we're talking about the question that we ask, we want to realize how much a specific car is worth. You need to realize what are the feature algorithm you should use and what are the actual accurate parameters in order to tune everything. So it's really complicated. So when you're talking about the features, Azure Automated Machine Learning can select, for example, 3 different features and generate this gradient boost algorithm and fine-tune these criteria, loss, mean sample split, and other parameters, and achieve this precision in this model. For every training model with different features, you can interrogate and try to understand what is the reason that you achieve 95%. On this example, you can see that mileage, regulation, car accuracy of 95% compared to a 70% model. Okay, so it's a self-explanatory model that allows you to understand why the score is given to a specific model. For example, I want to take you to everyday scenarios that might happen to you when you are building your models, whether it's your first one or not. So everything starts with data. So it's locating your storage, and you want to ingest the data and prepare the data using a normalization and transfer everything and validate the model, actually prepare the data from end to end. And then you start building the model itself and tune the run a hyperparameter tuning and automatic model selection. And in the end, you reach an error, a testing error. What does it mean? Or how can you handle it from that? That's all. This routine, these pipelines allow you to retrain and tune the hyperparameter and run through all this process, deploy the process, and at the end, reach it to production, whether it's for batch processing or real-time processing. This routine is for the building and deploying the next, when you achieve or get a new data, the only step that you need to run through is the normalizing transformation, and at the end, the batch scoring in this scenario. Again, it might be even in a real-time scoring. The advantage of Azure Machine Learning pipelines include an unintended run, reusability. It's really easy to reuse everything. You can create template of pipelines. You can set a specific scenario for retaining and batch scoring. It's really easy at the end to take everything, to deploy everything to production. You can track the different versions using a pipeline SDKs. You can mix and diverse compute. Simple deployment is one of the most important things. So you won't just build the solution. You won't just make this tons of sense and build this logic and no one can at the end consume it. So it's really important to simplify the way deploy to production. Okay, so Azure Machine Learning allows you to deploy, like I said, the solution really, really easy, one click from productionize. Azure Machine Learning deployment model you can run on scale. When you're using, again, Azure, it's really easy to figure out how you can do it. You can enrich the data while using cognitive services like I showed you earlier at the beginning of this session. You can enrich the data from different visuals or sounds, or if you want to translate from voice to text or text to voice using different languages, you can use an external experiments or external models that other data scientists want to share with you as one of the input of this process. You can register every model, you can score the different files, create a different Docker containers and deploy it to the destination. In the end, you want to monitor everything and to understand whether the model is accurate or you need to regenerate everything in production. It's really easy to embed it into a code or other location like Power BI, for example, or other BI tools. Okay, so I'm pausing now